Hello, and welcome to the CoHE Refresher Training. Thank you for taking the time to review this important safety procedure designed to keep you safe in hazardous energy scenarios that may arise in our plants. Your safety is our #1 priority, and we are confident that by understanding and using this CoHE training effectively across all levels, we can achieve our target of 0 incidents and make Toyota a safer work environment. Purpose and objectives. This training will refresh authorized individuals on Toyota's control of hazardous energy program, emphasize that lockout is the primary method of energy control, understand when lockout is required or alternative control measures, ACM, may be permitted. Review lockout procedure. And finally, recognize the hazards pertaining to improper lockout or ACM. There is one uniform standard that applies across the entire North America region. After this CoHE refresher training, you will be familiarized with the circumstances that may lead to a lockout or ACM procedure, when to move forward with lockout versus ACM, and all proper steps and protocol to safely perform the required procedure. Scope. The Toyota Regional Control of Hazardous Energy Standard applies to circumstances related to performing maintenance or service on equipment. In some scenarios, the unexpected energization, startup, or release of stored energy by the machines or equipment could harm employees. Employees in production, maintenance, facilities, engineering, and administrative sectors are most likely to be affected, though other groups could be affected as well. The CoHE standard establishes minimum performance requirements for the control of hazardous energy in our plants. Why is CoHE important? When working with machinery, employees may encounter the following types of hazards: mechanical, electrical, thermal, noise, vibration, radiation, chemical, ergonomic, falling, loss of stability, and slip, trip, fall. If you are unsure if a situation is safe, always remember to stop, call, wait. Most of these hazards can be eliminated with the correct CoHE procedure. Incident examples. The best way to showcase why CoHE is important is by reviewing real examples of incidents that occurred in our plants. Incident number 1. In Incident 1, a skilled team member was responding to an andon call. The clamp on the front floor cross machine was sticking, and the team member needed to troubleshoot the problem. To begin, the team member pushed an emergency stop and applied a lock on the control device. The TM then checked to ensure no machine movement by attempting to master on the equipment prior to entry. Once confirmed, the team member then entered the cell and leaned over the clamp to investigate. The team member discovered the clamp was sticking in a closed position. The TM then sprayed lubricant onto the clamp to resolve the sticking issue. The clamp then released after becoming unstuck due to residual pressure left in the system. As a result, the clamp struck the team member's safety glasses and face above the left eye, leaving lacerations. Throughout this process, the team member did not isolate the equipment and subsequently did not properly release the air pressure powering the clamp or perform a risk assessment to verify if the entry method was adequate for the task. As a result, that residual pressure in the clamp cylinder caused the clamp to release, resulting to facial injuries for the team member. Incident number 2. The second incident involved a maintenance team leader. The team leader was called to respond to a clog in the waste oil separator drain line. The individual disconnected the drain line from the waste oil separator side and began to investigate the location of the clog. In order to visually verify the clog removal, the team member removed the guard cover, exposing the running chip conveyor. The maintenance team leader then attempted to separate the drain line hose from a 90-degree pipe fitting on top of the conveyor housing. The individual applied force to the fitting by hand. Their hand slipped and was fed into the running chip conveyor. The team leader's arm was caught between the chip conveyor flight and the upper side of the conveyor frame. Before attempting to fix the problem with the waste oil separator, the team member did not perform any isolation or alternative control procedure prior to repairing the oil separator drain line. This incident could have been avoided if an isolation or control procedure was followed. Lockout. It is important to know that there are 3 types of team members involved in lockout operations: authorized, affected, and others. Authorized individuals are team members who perform the energy control and maintenance procedures. These individuals may be maintenance or production members who will perform the tasks that require control of hazardous energy. Authorized team members must know how to identify sources of hazardous energy, understand lockout placards, Identify hazards associated with machines and equipment. Be familiar with energy control devices. And know how and when to apply lockout. Affected individuals are team members who are required to operate the equipment being serviced or who are in the area of the lockout work. These individuals do not perform lockout procedures. Affected team members must know the purpose of lockout, recognize energy control devices, leave energy control devices on the appropriate equipment when found, and identify lockout locks and tags. Other individuals may be visitors in the area or anyone else that does not fall into the authorized or affected categories. These individuals must understand how to identify lockout and the associated hardware. In order for that to happen, they must know not to disturb locks or tags that have been placed on equipment. This particular category of team members likely will not be as familiar with what hazards to look for, and it's important to point out when lockout tagout is occurring to help keep them safe.